Okay, number 13. Simply supported beam with a length L equals 11, carries a load P at the midspan, and the cross-sectional dimension of the beam is B, 5H7, and if the allowable stress, shear stress, is 120 psi, determine the maximum load that may be applied. Can be a very straightforward calculation. Again, we just need to use this equation. It is a tau equals VQ over IT. Here we just need to determine all of those terms. As V in this case equals P over 2, since the P is the value that need to be determined, so we do not know it. Here the Q max equals, we have that equation, that is a BH square over 8, or 5 by 7 square over 8. That is 30.625. Right, over I, this is simple. This is a BH cube over 12. Right, so you get a 5 by 7 cube over 12. And this is 124.9167. And the T, in this case, equals B, right? That is 5 inch. So in this case, we know the allowable shear stress, right? We know the allowable shear stress that is tau allow equals V by Q max over IT. This should be smaller than 120 psi. So that is V by 30.625 over 124.9167 by 5, smaller than 112. And this V should be not higher than 2,800 pound. Why, since our V equals half P, right, so the applied P should be not higher than 2V, or no, we should write it in this way. V equals P equals 2 times V. This should be smaller than 5,600 pound. So that is a B. Okay, number 14. Well, 14, a W200 by 80 steel wet flange beam is I have been given, the depth have been given. So the depth means just from the top of it to the bottom of it, right, from the top to the bottom. That is 257. Since the I is given, in the first step of this calculation, you just add 2 plates. Here is the first plate, here you have the second plate, to strengthen this W-shaped beam, so that you determine the shear flow in the welding in terms of shear force. Right? That means the calculated Q should be a function of V. Right, so here the I of this W-shaped beam has been known, but we just need to determine the overall I. The overall I total equals I of this W-shaped beam plus it is 200 by 10 cube over 12. Since one of this plate, if you look at one of this plate, it is 200, the thickness is 10. Right, the size has been given here. Plus the AD square. Right, again, this A is 200 by 10, and the D should be half of the depth of the W-shaped beam, 257 over 2, plus half of the thickness, 10 over 2, right, square. Here is A, here is a D. Right, so this part together is is this I of one of the plates plus its AD square. But since you have a top plate, you have a bottom plate, so this part will need to be multiply by 2. The whole part needs to be multiplied by 2. Right, so this result will be 126 by 10 to the 6 plus 71.3 by 10 to the 6, and it will be 197 million mm to the 4th. So this is the total, the overall I. Then we need to determine the Q. Right? The Q. Well, now since we're calculating the shear flow in the welding, so when we cut, we just only consider this plate, since this plate is welded to this W-shaped beam. Right? We just cut this area. So this Q can be calculated by AD. In the A is 200 by 10, and the D, as we just determined there, right here, the D we have already determined, that is 257 over 2 plus 10 over 2. Right, so the Q will be 2.67 by 10 to the 5th mm cube. Then the shear flow can be calculated by VQ over I. Right, this is V by 2.67, 10 to the 5th, and over 197 by 10 to the 6th. And this is V over 738. Right, the answer is this.